All right, so in this section, we will learn the object-oriented concept. First, we'll learn what is object-oriented programming concept. And then we'll learn the object and class. Then we'll learn the access modifiers. Then we'll learn some naming conventions. And we'll have a look at constructors. And then we'll play around with packages. And then we'll put together what is a static keyword and how the heck can I use it. And then we're going to cover nested and inner classes. So stick with me. This is going to be a bumpy ride. Object-oriented program, OOP, or OOP, is a method of designing and implementing software. So it covers a pretty broad range. But the primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. It simplifies the software development process and the maintenance process by providing some concepts. And these concepts are object, class, inheritance, polymorphism, abstraction, and encapsulation. So we're going to cover these subjects in detail in the upcoming slides. First, I want to start with the object-oriented concept. Object and class. So a class, it's a group of similar entities, right? An object can be defined as an instance of a class. So objects are often used to model real-world objects that you find in everyday life. A Java object is a self-contained component which consists of methods and properties. An object contains an address and takes up some space in memory. A class doesn't consume any memory space. So an object has three characteristics. It has a state, behavior, and an identity. So coming up in the next slide, we're going to try to understand the characteristics. Characteristics of object. So just as I promised, an object has three characteristics. It has a state, behavior, as well as identity. The state represents the data of an object. Now, the behavior represents the action of an object, such as start, stop, etc. Identity is used internally by the Java virtual machine to identify each object uniquely, right? So the value of ID is not visible to the external user. So let's think about maybe a car, and let's call it a Ferrari. The color is red. The model is 2015. These are the states, right? So this car starts and stops. So starting and stopping are behaviors. Object and class example. So let's make an example with objects and class. For instance, we define a car class, and the properties of an object car would be model, color, and year. An object also executes some actions. A car is capable of performing the following actions, right? Start, stop, and accelerate. Now, as you can see on the slide, for different values of properties, model, color, year, in the class car, we will get different car objects. So in our example, we have one class, but we also have three objects. Cool. Class declaration. Every Java application must have at least one class definition. A class is declared by use of the class keyword. The class body is enclosed between curly braces The data of the variables are defined in the class, and these variables are called instance variables. The action code is written in the method, and all code blocks are in the class body. So variables and methods are defined in the class, and these are members of the class. Creating an object. An object is created from a class. In Java, the new keyword is used to create new objects. And as you can see here in the slide, we created my car as an object from the car class by using the new keyword. So car, my car, equals new car. And here, my car, the object, is the reference which holds the memory address of the car object. So in this section, we will learn access modifiers in Java. Access modifiers are used for setting the access level to classes, variables, methods, and constructors. There are basically 4 access modifiers in Java. First one, of course, is default, by default. So that means that we will not explicitly declare an access modifier for a class, field, method, and constructor. A variable, method, and constructor declared without any access control modifier is available to any other class in the same package. The second one is public. Public access modifier is accessible from everywhere, and this is the least restrictive access modifier. And the third one is private. The private access modifier is accessible only within class. So methods, variables, and constructors that are declared private can only be accessed within the declared class itself. Private modifiers are the most restrictive access level. So the last one is protected. The protected access modifier is accessible only within the same package and in addition from all subclasses of its class. So in this part, you see the restrictive level of accessibility of modifiers. And as you see here in the slide, the most restrictive modifier is private, and the least restrictive modifier is public. Default comes after private, and protected comes after default. So in this section, we will learn naming convention rules in Java. Java naming convention is a rule to follow how to name your identifiers, like class, variable, method, etc. But it's not enforced. You don't have to follow it. It's known as a convention, so that means it's just a mandatory rule. Guideline, if you're a fan of Pirates of the Caribbean. Anyway, as you see here in the table, the class name should start with an uppercase letter and should be a noun. For example, string, car, system, etc. The method name should start with a lowercase letter and be a verb. For example, start, stop, action performed, etc. The variable name should start with a lowercase letter. For example, first name, year, color, etc. And then by using standard Java naming conventions, you can make your code easier to read for yourself and for other programmers. The readability of a Java program is very important. It indicates that less time is spent on how to understand what exactly the code does. The most important concepts of naming conventions are case-sensitive and camel casing. So Java is a case-sensitive language. For example, hello with the first letter as an uppercase and hello with the first letter as a lowercase are, well, they mean completely different things in Java. Camel casing is a naming convention in which the first letter of the second word in a compound word is capitalized. So you have a name that is combined with two words. The second word will start with uppercase letter always. For example, action performed, first name, etc. Constructors. A constructor is similar to a method. It has the same name as its class. And when a new object is created, at least one constructor will be invoked. Every class has a constructor that is named default constructor. However, constructors have no explicit return type. Now, as you can see in our example, a class can have more than one constructor. So in order to understand the working of a constructor, take this for an example. Let's say we have a class car, and when we create two objects of car, in creating the first object, the new keyword here creates the object of class car and invokes the default constructor, has no parameter to initialize the newly created object. And then in creating the second object, also the new keyword creates the object of class car and invokes the constructor that has one parameter to initialize the newly created object. So let's show you some visual examples about working with constructors. So first, let's create a new Java project. And we can specify the project name as object-oriented. Now don't bother changing the other options and just click the Next button. So in this section, just uncheck the Create Module info.java file and then press the Finish button. So in this project, just right-click on the source folder and select New Class. So specify the package name as OOP concept, OOP concept, and the class name is car. Okay, so we create a car class. The states of the car are model and current speed. We declare them as a private identifier because we cannot have access to these variables from another class. So now let's declare a public constructor that's named car, and it takes one parameter, and its name is model. So we declare the constructor as public because we want to be able to access this constructor from another class. So in the constructor method, we assign a parameter to own variable model. This keyword is used to access the same class members. Now don't worry, we will cover this as a keyword in the next slide. So let's declare 4 public methods of the car class. And we declare it as public because, of course, we want to have access to these methods from the other classes. Now, the name of the first method is start with void type. In the start method, we use the print method to display car has started as our message by adding the variable model. The name of the second method is accelerate. So we add 20 miles per hour to the current speed variable by using the add and assignment operator. Then the name of the third method is stop. So in the stop method, we use the print method to display the car has stopped message by adding the variable model. Also, we can set the current speed to 0 because if the car stops, then its speed, of course, is 0. Now, the name of the last method is showSpeed. And in the showSpeed method, we can use the print method to display the current speed of the car by adding the variable model and current speed. So let's save the code. All right, so we're going to need to test this class. So let's create a new class. Right-click on OOP-Concept package and select New Class. Specify the class name as CarTest, and then select the checkbox for the main method. So let's create the MyCar object by using the new keyword. So we pass Ferrari as a parameter to the car class. This process invokes a constructor having one argument. So let's call the methods by using the MyCar object. We can access the properties of an object with a simple dot notation. So if we write MyCar dot, Eclipse automatically brings the properties of class, and we can choose them to add to our code. So we add the start method first, and then accelerate, and then show speed, and then stop, and again, show speed. Okay, so let's run the code in the test class. So you see the results in the console right here. The start method is called and it displays the Ferrari has started message. The accelerate method is called and it sets 20 to the current speed variable. The show speed method is called and it displays the current speed of the Ferrari is 20. The stop method is called and it displays Ferrari has stopped and set 0 to the current speed variable. The show speed method is called again and it displays the current speed of the Ferrari is 0. Okay, so you are now ready to learn the toString method. Been waiting for this. So let's declare two variables in the car class. The first one is color with string type, and the second one is year with int type. So let's declare a constructor that's named car, and it takes three parameters: model, color, and year. All right, so in the constructor method, we can assign the model to its own variable model, color to its own variable color, and year to its own variable year by using the this keyword. So let's declare the toString method of the car class, and the toString method returns string. Now, we return name, color, and the year variables by using the plus operator in this method. So let's save the code. Okay, so let's pass the test class CarTest, and let's create a new object. So its name is MyCar1. Now we pass three parameters to the car class. They are Ferrari, red, and 2015. And now we add the object mycar1 to the print method. Now, if you print any object, the Java compiler internally invokes the toString method. So let's run the test class again. And do you see the result in the last statement? Of course. The toString method is called and it prints model is Ferrari, color is red, and year is 2015. So let's open the car class, and we invoke this constructor and the toString method of the car class. Packages. A Java package is a group of similar types of classes, interfaces, and other sub-packages. Now, if you have a large-sized project that consists of hundreds of Java classes, you really need to organize them into packages. You can think of packages like file directories in your PC. So this will allow you to categorize files, control access to your classes, and avoid potential naming conflicts. Classes with the same name can be put into different packages, so then packages avoid name collision. So the package keyword is used to declare a package. In our example, let's declare a package vehicle.car. So here, vehicle is a top-level package and car is a sub-package, right? Now, of course, there are some rules to define packages. Package declaration is done at the beginning of the source file. Only one package declaration can be done per source file, and if no package is declared, then the class belongs to the default package. And the package name must be hierarchical and separated by dots. Types of packages. So we have two types of packages in Java. Built-in package, the already defined package like java.lang, **, java.io, **, etc. They're known as built-in packages. You can also have a user-defined package. So the package we create is called a user-defined package. For example, the one that we used earlier, vehicle.car. That's a user-defined package. Import keyword. So we can use the import keyword to import built-in and user-defined packages into our Java source file. Our class can refer to a class that is in another package, and we can use its name directly in your class. We can access the classes and interface of another package with the import keyword. So we have two different ways of how to import any class into different packages. The first one, if you import the package name .class name, then only this class will be available for use. For example, you see this on the slide. If we use import vehicle.car.ferrari, that means that we will use only the Ferrari class in the sub-package car in the top package vehicle. Yeah? So the second way to import, if you use a package name .asterisk, then all the classes and the interfaces of this package will be accessible, but the classes and the interface inside the sub-packages will not be available for use. Now, there is one exception to the import rule. All classes in the java.lang package are imported by default. But that means that we do not need to import classes in the java.lang package into our code. The system class can be given as an example for this exception. The system class is predefined in the java.lang package. so we can use it in our code without importing. Sequence of program. So as you see here in the diagram, in Java, a Java source file can contain any or all of the following three internal parts: a package statement, import statements, and a public class declaration. A Java source file should have a public class declaration. All other statements are optional. The program should be written in a flow package with imports and class. So why don't we do some examples with packages? In fact, we did an implementation of packages in all of our earlier examples, but we do need to learn the package concept, I think, in detail. So let's get into it. So in the object-oriented programming project, just right-click on the source folder and select New Package. Specify the package name as Package Operation. Okay, so let's create a new class. Right-click on Package Operation and select New Class. Now specify the class name as Multiply, and it means that the Multiply class in the Package Operation package. So let's start to code. Let's declare an int method, multiply, with two int parameters, a and b. And we return a multiply b expression from the method. Now let's create a new package for the test. Right-click on the source folder and select New Package. Specify the package name as Package Test. Okay, so let's create a new class. Right-click on the Package Test package and select New and Class. Specify the class name as Test and select the checkbox to add to the main method. Now, first we need to import the scanner class for getting the input from the user. And we choose the import scanner class in java.util package to import the scanner class. Java.util is a built-in package. And now we see a message to enter two numbers by using the print method. So why don't we go ahead and declare two variables that are named number 1 and number 2 with the int type, and assign the next int methods of the scanner class to these variables. Great. So now let's create an object from the multiply class by using the new operator. So the multiply class is not part of this package, so we got an error, right? You're expecting that? So what does that mean? We've got to import this class. Now, in order to import this class, just hover your mouse pointer on the multiply keyword and import options are shown. And we'll choose the first option, import multiply in package operation. Okay, so it looks like it's added after the scanner class definition. Now, this is what we would call a user-defined package. So let's print the multiplication of numbers, and we will call the multiply method of the multiply class, and we pass two numbers as parameters. Okay, so let's run the code. We enter 12 and 8. The multiply method in the multiply class is called, and it displays result is 96. So let's try to change the access modifier of the multiply method in the multiply class. So if we change the public to private, and let's save the class. So see how we get an error in the main method because the method multiply is not visible to the other class. So in these cases, Eclipse can show us a quick fix dialog. Now this dialog provides a whole list of possible corrections. Now, if we want to solve this problem, just select Change Visibility of the multiply method to public option. Okay, so let's open up the multiply class and see our changes. Let's create a new class and specify the package name as method operation and class name as add. Let's declare an int method add with two int parameters a and b. We return a plus b as the expression from the method, and we'll save the class. Now let's open the main class test. We have two classes in the package operation package, multiply and add. So if we use the asterisk mark after the package definition, we can access all of the classes in this package. So let's create an object from the class add. And see how we didn't get an error, so there's no need to import this class. Let's print the sum of the numbers. We call the add method of add class, and we pass two numbers as parameters. Okay, let's run the code. We'll enter 12 and 8. So the multiply method in the multiply class is called, and it displays result is 96. Add method in the add class is called, and it displays result is 20. In this section, we'll explore the static keyword of the Java language in detail. We'll learn how we can apply the keyword static to variables, methods, blocks, nested classes, and just see what difference it makes. So the static keyword is used for memory management in Java. It's a keyword that is very useful, and it's used for sharing the same variable or method of a given class. Static keyword usage. So have a look at this slide. We use the static keyword to declare static variables, methods, blocks, inner class. And also, we'll be able to define the static method in interface classes in Java 8 and later. Static variable is used for fulfilling the common requirement. For example, a school name of students. The school name is common for all students, so if we declare static school name variable, it'll allocate memory only once in the class at the time of class loading. A static variable can be accessed directly by the class name, and it doesn't need any object. Now, the static method is a method which belongs to the class and not to the object, right? A static method can be accessed directly by the class name and doesn't need any object, same as a static variable. Static block is a block of statement inside a Java class that will be executed when a class is first loaded into the Java virtual machine. And we will also cover nested class and interface in the next slides. But for now, let's make some real-life examples by using the static variables and methods. So in the Object-Oriented Programming project, just right-click on the source folder and select New Class. Specify the package name as static example and the class name as car. So let's start to write a program that implements speed operations of a car by using static variables and methods, such as show speed, speed up, speed down, and stop actions. Now first, let's declare two static integer variables. First one is current speed with the initial value of 0. And the second one, max speed with the initial value set to 180. So now let's declare a static void method that's named showCurrentSpeed, and we'll give it a parameter that's named speed. So we will use this method to print the current speed by using the print method, and we're going to call this method from the other methods in this class. So we'll write a method once, and then we can use it multiple times, right? We do not have to rewrite the entire code each time. You remember that from earlier? So let's declare a static void method that's named speedup, and we'll give it a parameter, call it increase. So in this method, we'll assign the current speed plus variable increase to current speed by using the add and assignment operator. So if the current speed of the car is greater than the max speed, then we show the current speed. And also, we can give the please slow down message by using the print methods. So if the current speed is smaller than the max speed, that way we only show the current speed by calling up the showCurrentSpeed method. So let's declare another static void method that's named speedDown, and let's give it a parameter called decrease. So in this method, we'll assign the current speed minus variable decrease to the current speed by using the subtract and assignment operator. All right, that makes sense. So then we show the current speed by calling up the showCurrentSpeed method. So let's declare the third static void method that's named stop, and that one, of course, has no parameter. So in this method, we just assign a 0 value to the current speed variable, and we show the current speed by calling the showCurrentSpeed method. Okay, so let's create a new class for the test of car. Right-click on Static Example and select New Class, and specify the class name as Test, and then just select the checkbox to add it to the main method. Now, a static method can be accessed directly by the class name, and it doesn't need any object. So let's call the methods of the class by using the class name directly. So first, we call speedup and pass the value 60 as the parameter for increasing speed. Then we call the speedup method again and pass the value 100 as a parameter for increasing speed. Then we call the speeddown method and pass the value of 50 as a parameter for decreasing speed. And then finally, we can call the stop method. All right, so let's run the code and review the results. So the initial value of speed is 0, and look at that, we speed up to 60, and the current speed is 60. Then we speed up to 160, which is 60 plus 160. So the current speed is 220, and 220 is greater than the max speed value of 180. So we get the please slow down message. And then we speed down 50, and 220 minus 50, and the current speed is 170. And then finally, we stop the car and set 0 to the current speed. Wow, what a ride. So, if we try to create a car object by using the new keyword, let's call the speedup method and pass a value of 40 as a parameter. Now, there's no error, but we do get a warning message that the static method speedup from the type car should be accessed in a static way. So this code works, but it's not recommended to do it this way. All right, so let's run the code, and you see the same results. So how about that? I think that greatly develops your understanding of what a static variable and a static method is. You can review the material, of course, or you can take what you've learned and move along to the next bit. Nested and inner class. So in Java, we may define a class within another class, and this class is known as a nested class. There are two types of nested classes in Java. First one is non-static nested class, and that's known as an inner class. And of course, the second one is the static nested class. So let's talk about non-static nested classes first. So non-static nested classes, or inner classes, may have access to all the members, such as static and non-static variables, methods of its outer class. Also, an inner class may access private variables and methods of its outer class. Static nested classes do not directly have access to other members, such as non-static variables and methods of the enclosing class, because it is, by its nature, static. I tell you what, let's clear it up by doing up some examples, and that'll help us understand it better. So in the Object-Oriented Programming project, just right-click on the source folder, select New Class, specify the package name as Nested Class, and the class name as Static Nested Example. So let's start to write a program that accesses variables from the nested class. Okay, so let's declare a static int variable a with an initial value of 5. And let's declare a private static int variable b with an initial value of 10. Now let's declare a non-static variable c with an initial value of 15. Okay, so let's try to access these variables from the static nested class. Now we need to, of course, create a static nested class in this class. So let's create the static nested class that's named static nested class. So in this class, we create a void method, and we'll call that show. Now in this method, we can use 3 print methods. So in the first print method, we can access static variable a. In the second print method, we can access private static variable b. And in the last print method, we cannot access non-private static variable c. This statement gives a compilation error because the static nested class does not have, it cannot, it won't ever have direct access to a non-static variable. So, what do? We'll put a comment on this line. Okay, so let's create a new class for the test of the static nested class. right-click on the nested class package, and then select New Class. Specify the class name as Static Nested Test, and then select the checkbox to add to the main method. Now, in order to access a static nested class, we first use the outer class, and then we use the dot operator and nested class. Outer class is static nested example, and the inner nested class is static nested class. So now let's create a nested object by using the new keyword. And we'll call up the show method to print the values of the variables. Okay, so let's run the code. And you see the values of the variables, a equals 5 and b equals 10. So now let's do an example with inner class. Now, I always like to think of myself as having inner class. But let's create a new class. Right-click on the nested class package and select New Class. Specify the class name as inner class example. And then let's copy the declaration of the 3 variables from the static nested example class. Okay, now let's try to access these variables from inner class. We need to create an inner class for this class. So let's create an inner class that's named inner class. So in this class, we need to create a void method called show again. And we'll use 3 print methods. In the first print method, we can access the static variable a. In the second print method, we can access private static variable b. The last print method, we can access non-private static variable c. This is an important point, right? In the static nested class, we couldn't have access to variable c, but we can access in the inner class, right? Okay, I'm glad we cleared that up. Let's create a new class for the test of inner class. So right-click on the nested class package and select New Class. Specify the class name as inner test, and then select the checkbox to add to the main method. Now, in order to instantiate an inner class, we must first instantiate the outer class. Then create the inner object within the outer object. So let's create an outer object by using the new keyword first, and then we'll create an inner object. Okay, so let's run the code. And you see the values of the variables. A equals 5, B equals 10, and C equals 15. Excellent. Very well done.